We're going to look at the square root functions and talk about how it relates to the different functions we've been looking at so far. We're going to start with the warm-up. Sketch the following function, y equals -2 times the absolute value of x minus 3 plus 5. So the first thing I ask for is the vertex. The vertex is where it changes direction. For the parent function, the vertex is at 0, 0, and that's when your V shape goes from down to up. Let's look at inside the absolute value, which is like parentheses. The -3, we know, shifts this to the right 3. And the plus 5 shifts this function down 5. So if we go right 3, down 5, the vertex would be +3. And then down 5 would be a -5. So there's our vertex. Let's graph that as a coordinate. So if we go right 3, down 5, here's where it changes direction. We know it's a V-shaped graph, and we talked about how that number right on the outside of the absolute value is kind of like the slope. And here that A value is -2. So what that means is from our vertex, we're going to go down 2 over 1. So actually, I'm going to redo this. Give myself more room here. Okay, so again, the vertex was 3, -5, and we're going to go down 2 over 1, down 2 over 1, and if we extend our line here, here's what the graph looks like. So today we're going to look at square root functions. It says on a graph page on your calculator, graph the new parent function y equals the square root of x. Okay, so let's open this up, and square root is control x squared. Here's the x. So there's the square root of x. And it says, why are there no negative values? Let's fill in the following table and sketch a graph of the function. All right, let's go back to A. Let's fill in the table first. If we have y equals the square root of 0, that's just 0. For our next value, we have y equals the square root of 1. That's 1. For y equals the square root of 4, that's 2. And y equals the square root of 9, that's 3. So if we graph that right here, we have 0, 0, 1, 1, 4, 2, and 9, 3. So here is our function graphed. And we can see how it matches this right here. So the question is, why are there no negative values? And the reason is, you can't take the square root of a negative number. There's no number times itself that's negative. So we can write that here. You can't take the square root of a negative number. Because there's no number times itself that is negative. Okay, so this is our parent function today. Here's an important point to look at, 0, 0. And we're going to look at that and see how it shifts. Okay, so using what we already know from the previous days, make predictions. How do the following functions shift from the parent function y equals the square root of x? You can use your graphing calculator to check if you're not sure. Well, the +1, I'm going to guess, if it follows our patterns, is going to shift left 1. So let's try that. I'm going to hit tab. I'm going to type in the function x plus 1, and you can see from 0, 0, that point does shift left 1. Let's try the next one, -3, then I'll guess it shifts it right 3. Again, I'll go to tab and just edit my old equation, and let's do x plus 3. And it should have been -3, right? -3, so let's fix that. And we can see that it does shift right 3. How about this? The square root of x, the +4 is on the outside. I'm going to guess that shifts up 4. So again, let's type that in. And we can see it does go up 4. And -5 then would be down 5. Okay, so again, if I hit tab, minus 5. And it does go down 5. Okay, so now let's kind of go backwards. If I give you the shift, can you write the equation? If it goes left 5 and down 1, what will that look like? We have y equals the square root, and left 5 would be in parentheses, x plus, or under the square root, so you don't need the parentheses. You can put it if you want. So left 5 would be x plus 5, but then down 1 would be minus 1 on the outside. Right would be the square root of x minus 7. Up 3 would be plus 3. Left 2 would be y equals the square root of x plus 2. And then up 4 plus 4. And then right 8, square root of x minus 8. And then down 9 minus 9. So the same rules apply as that we've seen earlier in the unit. Okay, we haven't looked at this though, negative on the outside. So it says graph and sketch the following. So we know what the square root of x looks like. I'll call that graph 1. It kind of looks like this. So this is graph 1. But what about if there's a negative on the outside? So let's graph that. I'm going to delete this. Put a negative on the outside. And we can see that it's a reflection over the x-axis. So here's our second graph. All right, it's a reflection over the x-axis, which is like this line right here, a mirror line right there. What if the negative's on the outside of the square root? So let's take a look at that. So hit tab. Oh, negative on the inside of the square root, so I wrote that wrong. I'll have to fix that. All right, so if the negative's on the inside of the square root, then it's a reflection over the y. So here was the second graph here. Here was our original graph. So it's a reflection across this line, which is the y-axis. So if the negative's on the inside, it's a reflection across the y. If the reflection's on the outside, it's a reflection across the x. So we're going to practice these ideas today in the assignment, and then we'll go over any questions that you have tomorrow.